Okay, so we are doing the last problem on the optimization worksheet, which is number 7.
Yeah.
Okay, yeah, you can just treat it like a regular class. Hi guys at home. Everyone's now nervous about being on the recording. So this is the power station problem. So a power station is on one side of a river that is 0.5 miles wide. So basically the first thing you want to do with this problem is draw it. Exactly. So if you draw it, you get, so, all right, let me draw it the way there's a factory and a power station, right? I always draw the factory over here for some reason. And it really doesn't matter. I don't know why I do it this way, but I'm going to do it the way that it's in my notes so that I don't get confused. Okay, so here's my factory, my power station. We know that this is 0.5. Okay, and we know that this, maybe I'll do it in red. This is 6. What?
My diagram is not to scale.
It's no, yeah, no. I mean, mine isn't either, really. Are any diagrams really drawn to scale? Okay, it costs $6,000 per mile to run power lines over land and $8,000 per mile to run them underwater. Find the most economic path to lay transmission lines from the station to the factory. Okay, so everyone always asks, isn't it the cheapest to just do the 0.5 miles under and then 6 miles down? Right, directly. Do the 0.5 miles directly under and then it's actually not. It's not cheaper to do that. It's cheaper to set it up a different way. And we will see that in a minute. We can compare those answers. Yes?
How do you know where the power station is?
It just says that a power station is on one side that is 0.5 miles wide. The factory is 6 miles downstream of it. I mean, is downstream on the other side. So it's just one of them is 6 miles downstream. Oh, I mean, these probably should be reversed, actually. Can we? If you're saying that going this way is downstream,
Yeah.
then
Like,
does it matter? It doesn't really matter.
is it like next to the stream?
Oh yeah, they're just like on either side.
Oh.
Yeah. Oh, I see what you're saying. Okay, should we make this now the factory and this the it really doesn't matter. Okay, so the question is, we'll worry about the money in a little bit, but I need to set up a picture that will help me minimize cost. So if I told you it's not the cheapest thing to go just directly 0.5 miles under and then 6 miles down, how do you think I'm going to set up a picture? Yeah, Izzy's got the right face. This is hard. This one's really hard.
I don't understand where to go.
So let's say,
Just go straight across.
well, right, so,
You don't know that there are lines that way, right?
wait, what? You're still hung up on the, hung up on the,
like this is 6 miles, and then the power station's like over here, so you can't go straight across.
right, no, I know, we're suspending disbelief here. She's like, what if the power station was, or the factory was actually over here, right, and not right here? Isn't that what you're asking?
Kind of.
Yeah, but like, we're just assuming that,
Downstream or...
well, no, we know they're 6 miles apart.
Oh, that's what it means.
Yeah.
I thought it was that the factory was 6 miles long.
Oh boy. Nope. That is not what that means.
Don't you just do a straight line?
Well, that's what so wait, so
It's a triangle.
it's a triangle.
Okay,
It's
so
going to be a triangle. Right, so it's going to look like this. So this will be our path for the power line.
Why would it be straight? Oh.
I know.
No, I get it.
No, but it looks like it would be cheaper to just go 0.5 miles across and then 6 miles down, but it's not. Because you lose so many miles this way.
But why wouldn't you just go downstream? Like,
This
assuming
way.
That's all. No, like completely just like.
You mean like completely just diagonal?
Yeah.
Oh, like this?
Underwater is more expensive.
Because going underwater is super expensive. Not super, but it's more expensive. Going
So you
under.
have to find like how much
Right, so you might get that it actually, like, if you were to do this problem and you didn't know, like me, didn't have foresight, you might get that, like, this part was 0, and this was all of the, but it will not be like that. But that's not that's not bad thinking. Okay, so I'm gonna pull out some, like, if we were to take out kind of these shapes we've made, so, like, you might see that there's a right triangle right here. Like, this is basically what it's going to look like if you didn't have the river or the factory there. Like, if you didn't have anything else in your drawing besides basically the distances, then, like, what is this distance?
0.5.
That's 0.5, right? No, that's a right angle, because we need a right angle. That's 0.5. Okay, we know that this whole thing is 6. Let's break it up. So why don't we call one thing
X.
x
And 6 minus X.
and 6 minus x. What do you think about making the hypotenuse y? Why not? Okay. So now, the unfortunate part about this problem is all the work that follows this, which is kind of ugly and annoying. I mean, I guess it's not as bad as that rectangle problem, the box problem we did. So
That one just wasn't clear.
yeah. Oh, wasn't clear?
Well, because, like, I understood what the girth was, but I didn't know what.
Oh, I meant the other one.
Oh, this one.
Yeah. Yeah. Okay, so we need an equation with cost and we need an equation without cost. That's usually how these cost ones work.
So it's like.
Yeah, so what is the equation? What's the equation with cost? Let's do that one first, maybe.
6,000 y, yeah.
No, 6 minus x plus 8,000 y.
Well, but there has to go something goes in front of the 6 minus x.
6,000.
Oh, 6,000. Yeah, sorry, if you said that in. 6 minus x plus 8,000 y. So that is the equation with money in it, because you're going to need something with money. Okay. Then you need another equation relating x and y.
Y plus 6 minus x equals.
I thought it was going to be x squared
Ding, 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 ding.
0.25
Oh.
Yep.
y.
And
Oh, then you plug it in.
y squared equals 1/4 plus x squared.
That's so sad.
We only have to worry about the positive square root. Well, no, someone always asks, what about the negative square root? Like,
Really,
I know.
in real world.
We're going to have a negative answer for y, but you know what? People hold on to those algebra rules, like, for dear life. Okay, so we've got these two equations. I'm actually going to go to a new page.
Well, you want to plug in y first and then you find the derivative of
What?
What do we want to?
Plug in y.
To the cost equation,
And
and
then find the derivative.
exactly.
Find x or find the derivative? I feel like there's derivative in here.
Find the derivative, which leads you to find
Find
x.
x.
Right.
Okay.
Okay, so what we're going to do is we need to plug it in,
I feel like we should just distribute.
or see if,
So wait, do you square everything?
do you square everything? For what?
You get rid of the square root 1/4 plus x squared.
But why would you use, we will eventually, just not right here. Not till after we take the derivative. Why am I struggling here? Times. All right. So just to tidy up a little bit. Okay, so now I'm going to take the derivative of this. Ugh. Okay, 8,000
Over.
and then don't forget to use the chain rule. Oops. Now we said this, so this will be 8,000 over the square root of 4th. Okay, so now we have to set this equal to 0, right? Because if we're doing optimization, right, we're maximizing, or minimizing, sorry. So
Wait, isn't it 8,000x?
Yeah.
oh, x, sorry, x, you're right. Yeah, I'm just gonna do some algebra here. Yeah, and now here you have to square everything. So I'm gonna, hmm? Sixteen minus 9 is 7, right? Wait, did I do this right? Okay, woo, found x.
Wait, how did you order the x squared?
Mean right here?
No, where to last?
This, I subtracted x squared from both sides? Like, are you talking about from here to here?
Yeah.
I subtracted x squared from both sides. I moved it to the other side. Because it's like terms with 16 over 9x squared.
Oh.
So I've got x. So then y equals, well, we know that it's 9 over 28. So then hopefully you would say something like this is below water. And this is above water. So yeah, it's not so bad, that one. It's just getting the picture can be tough. Yeah, the picture is hard. So, and when you have these cost ones, like did we do cost ones with related rates? I don't remember. So the cost, you just have to remember that you need two equations, and one of them will have cost and one of them will not have cost. That's really, because everyone kind of is sometimes confused about how to incorporate cost into it. And so that's how you would do it. And when you're minimizing or maximizing cost or money, that's the one that you're going to take the derivative of. So if that helps, figure it out. All right, that's it. So what do I want to do with them? Well, what do I need to do in general? Actually, I'm going to go